Hey everybody, today we're going to kick off the circles chapter. We're going to do circles lesson number 1, and we're going to start by talking about tangent lines. Now, those of you who know me as a teacher, you know that sometimes I talk about something random. It seems like I'm going to be going over something and I'm sticking to the topic and I'm going around and I'm going around and I'm going around, and then suddenly I just go completely off topic just like that. That's called going off on a tangent. You may have heard that phrase before. Going off on a tangent is when it seems like you're focused on something and then suddenly you change into something completely different. Sure enough, that right there, that example, is what a tangent line is. A tangent line is a line that touches a circle, but it doesn't actually go through it. So I know that seems like kind of a cheesy analogy to be using here for the circles chapter, but it fits perfectly. Tangent lines touch a circle, but they never go through it. Okay, so if you want to draw that on your paper, the best way to draw it on your paper, the best way to just make an example is to do a circle and then draw a line, and I want your line to go across the top of the circle, but it can't actually go through it. Okay, so it's going to touch it, but it's never actually going to go through it. That is an example of a tangent line. Now, there's actually something really interesting that you can use to tell if something is a tangent line or not. If you were to draw a radius or a diameter, okay, and you were to draw it from the center of the circle to the tangent line. Okay, so if you take your example that you just drew, it should look something like that. You might notice something about that drawing. You might notice something about the angle that we just made. That's a right angle. It turns out if you draw a radius or a diameter and it touches the tangent line, then it will be perpendicular to it, which actually means we can use this information to make a prediction about whether a line is actually a tangent line or not. If it's a tangent line, it's going to be perpendicular and it's going to make a right angle. Okay? Now, I think the easiest example for you to see is probably going to be example number 3 right here. And let me explain why. If AB is a tangent line, then it's going to make a right angle. And if it makes a right angle, then this is a right triangle. And what is the thing that we have been using with right triangles for the entire year? The Pythagorean theorem. So here's what we do to test. It says determine if AB is tangent to the circle. It's really just a yes or no question. All you need to do to test it is see if the Pythagorean theorem works. If it works, then it's a right angle, which means it's tangent. If it doesn't work, then it's not a right angle, which means it's not tangent. So, the example of this, you might wonder, like, how do you know if it works? What does it mean for it to work? Well, a squared plus b squared equals c squared, and all you have to do is throw the numbers in and just test it out and see if it works. 144 plus 256, and you can just get a calculator to test it out. It's all good. You're really just giving yourself a yes or no question. Yes, it checked out. No, it didn't. So is 144 plus 256 equal to 400? So again, hopefully you have a calculator out at this point, and you can just do 144 plus 256 is 400. That means bing, 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 it worked out. So determine if AB is tangent to the circle. Sure is. AB is tangent. All right, let's try one with harder numbers. Let's go on to problem number 4. Let's test it out, and we're going to do 11.4 squared. I'm going to run out of room, so I'm going to put it up here. We are going to go through the circle. That's okay. plus 15.2 squared equals 19 squared. I don't know these off the top of my head, so I'm going to have to actually use a calculator. So 129.96 plus 231.04 equals, and then 19 squared, that one I do know, is 361. So just test it out, yes or no. Is 129.96 plus 231.04 equal to what? Bing, 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 bing. Sure enough, it is. That means that's a right triangle. And if it's a right triangle, that means that that is a tangent line. So determine if it's tangent or not. Sure is. There you go. All right, we've done a couple of examples where it worked. You should probably see an example where it doesn't work. So let's try number 2 out, and we're going to do the same thing. It's just a yes or no test. 6.6 squared plus 11 squared equals 13 squared. Just a yes or no question. 6.6 squared. 43.56 plus 121 equals 169. So 164.56, that does not equal 169. That means AB is not tangent. All right, one last thing I want you to be aware of. Sometimes you have to get creative. Sometimes you have to figure out a missing piece using common sense. So for instance, if you look at problem number 1, they didn't give you this length right here at all. How in the world are we going to test if we don't even know what that length is? Well, it turns out we actually do know what that length is, because it says right here the radius is 12. And if the radius is 12, then it's going to be 12 no matter where you put it. It's going to be 12 right here. 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 That means it's going to be 12 right there. So that means 12 squared plus 16 squared equals, and then if you look at the hypotenuse, it looks like you've got a piece to the hypotenuse that is 8, and then a piece that is 12. You add that together, you get 20. And I don't have to actually show the work for this one because we've already done this problem. 12, 16, and 20, we already used those numbers on problem number 3. So I already know, bing, 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 it is going to work, and AB is going to be tangent. All right, pause it here if you need a second. We're going to move on to the next section. All right, the next section is where you have to actually solve for a missing piece. So in this case, now we're going to do this, and we've been doing this for a while with right triangles. The difference is now it says, assume that all lines which appear to be tangent are. And if it's tangent, then it makes a right angle. And if it makes a right angle, then we're going to use the Pythagorean theorem. So 4 squared plus b squared equals 8.5 squared. And from here, this is not really new to anybody. I feel like we've done so many of these that we're going to be just fine. So 8.5 squared. So it turns out b squared equals 56.25. I'm just going to subtract from both sides. And it turns out that missing length is 7.5. Now remember, if you were struggling at how to get that number, so we have b squared equals 56.25. To figure out what number squared gives you 56.25, the opposite of a square is a square root. So if you were not sure where I got that number from, I took the 56.25 and I did a square root. Okay, so that's where that number came from. All right. Now, if you look at problem number 6, we actually have two missing sides. We have a missing side here, and we have a missing side here. We know that that's going to be a right angle, but we don't have any other information. So this is where we have to get creative. Notice that the radius is 1.5. That means the radius is 1.5 no matter where you put it. Means if you put it here, it's 1.5. Here, 1.5. Here, 1.5. Here, now that's the most important thing, 1.5. So when we set up the equation, we're going to get 1.5 squared plus the missing piece b squared equals 2.5 squared. Now, this is going to look like it's going to be a really awful problem because you got all these decimals going on. 1.5 squared is 2.25. 2.5 squared is 6.25. Oh my goodness, what are we going to do? And then you subtract and you find out that b squared is 4. And if b squared equals 4, I don't think we even need a calculator. What number squared is 4? How about 2? And that was it. Now, you're going to notice that there are some numbers that are going to keep showing up. They're called Pythagorean triples, numbers that always work with the Pythagorean theorem. So people who are observant are going to get to problem number 7, and they're going to go through 12 squared plus 16 squared equals c squared, and then they're going to go back to the top, and they're going to be like, well, isn't it just going to be 20? That's fantastic. If you picked up on that and you already knew that the answer was going to be 20, then I applaud you. I'm glad. I'm glad we're picking up on some of these patterns. It turns out the missing side is 20. If you didn't know that, then the work is right here in front of you. Now, why did I use C instead of B for that problem? Remember, if the missing piece is the longest side, the one that's opposite the right angle, then you have to use C. If you're missing one of the legs of the right triangle, then that means you're going to use A or B. When it comes to a right triangle, A and B are interchangeable. I don't really care what you use for A and B, but C has to be the longest side. It has to be the hypotenuse. All right, one last one before we do our last section right here. So you look at problem number 8. We have a couple missing pieces, but remember what I said about a radius. If a radius is 6, that means it is 6 everywhere, which means this piece is also 6. So the way I'm going to set up this problem right here is I'm going to say 6.4 squared plus 12 squared equals c squared. And again, the missing piece is going to be the hypotenuse. So 40.96 plus 144 equals c squared. You throw all that up, add it together, you get 184.96. And this one, I definitely don't know that off the top of my head. So we're going to do the square root. And we're going to find out that the missing length was 13.6. There you go. All right. Now, there's one last piece to this puzzle that I want you to draw somewhere on your paper, and this is going to be part of our last definition. If two tangent segments, I'm going to have you draw this in just a second, are drawn from the same exterior point, they are congruent. So this is the drawing that I want you to think about, and you can put it anywhere on your paper. You may have a missing, you may have an open space on your paper somewhere. So take a circle, and then just draw a random point. I'm just going to draw my random point right here. If you were to draw a segment, so we're not going to draw a tangent line this time, we're just going to draw a tangent segment. It's going to make it to the circle, and it's going to stop. And then you were to draw another one. It turns out this and this are the same. They are the exact same length every single time. Now you're going to see on the back side, you can make an equation out of that. So like if this is x plus 4 and you find out that this one here is 3x minus 2, you could solve it. You could say x plus 4 equals 3x minus 2 because they are the same. Okay, that can be done. Now, in the case of problems 9 through 12, you're going to use a different purpose here. What you're going to do for 9 through 12 is going to be you're going to find the perimeter of each polygon. And what that means is we're going to use that strategy to try to make it around this thing. So if I told you that this was 10.5, then you'd say, well, that means this right here has to be 10.5. And then if I told you this was 11.2, then you'd say, oh, well, I guess that means that has to be 11.2. And then the last thing you would do is you would take what you know the whole thing to be over here, which is 23.2. You would take away what you already know to figure out what was left over. And what was left over would be 12, which means that is 12. Now, once you get there, you can just add up every piece. You can get 10.5 plus 10.5 plus 11.2 plus 11.2 plus 12 plus 12. You could do it any way you want. It doesn't really matter. But you would get 67.4, and I'm going to say units. Whenever we're talking about area, perimeter, that sort of thing, I think it's a good habit to talk about units, because then if I put something like 23.2 meters, then you would know that we're going to be using meters, and so on and so on. All right, let's slide over, take a look at problem number 10. So problem number 10, if you've got a 13 right here, that means you're going to have a 13 right here. Now, if the entire length of this side is 25, and you know what 13 of it is, you could subtract and figure out that the rest over here is going to be 12, which means that's going to be 12. And then you go on and you figure out that whatever is left over from 21.8 is going to be 9.8, which means this right here is going to be 9.8. So you can go on and you can use this strategy over and over again to figure out what you're missing. Then last but certainly not least, these will both be 4.6. So you add everything up piece by piece. And again, there's more than one way to do that. So if you are going to be more efficient about it than me, that's fine. I'm just trying to demonstrate what's going on. And you end up getting 78.8 units. All right, let's slide over and do just a couple more. You try these on your own as I do them right here and see if we come up with the same thing. So we get 14 and 14. The leftover from 14 is 9. 23 minus 14 is 9. That's where I got that from. Then you have a 9. And then if you have a total of 22.7, you take away 9, you get 13.7. Which means right here we're going to have another one. Try working it out. See if you get the same answer as me. All right, try the last one right here. All right, I'm going to trust your ability to add and subtract here. When it's all said and done, add up the pieces. All right, check it out, see how you did. So for those of you who are completing the online assignment, make sure you check closely so that you know which problems need to be completed on the back side of this paper. Thank you for watching. I hope that helped you out. I'll see you next time. Take care of yourself. Take care of each other.